Okay, welcome students to this lesson on addition formula. So the addition formula is a very interesting formula, but we want to first investigate one very important rule in sign in trigonometry. So it's sine of a plus b really equals to sine a plus sine b, and we're going to use some values here to investigate. So the first one we have here is, we have let's take a as 60 degrees and a as 30 degrees as b as 60 degrees. So if we add them up, that will be 90 degrees, right? So the sine of a plus b, if you use your calculator, it actually just gives you 1, or you can, if you know your trigonometry well. So what is then sine a plus sine b? Sine 30 is a certain value, and sine 60 is also another value, and it will give us 1 plus square root 3 over 2, which is not equals to 1. Okay, so we can also do the same for the rest. So the rest over here, same thing, a plus b here is 180 degrees, and then we have here as 0 degrees, and sine of 180 degrees 0. And last but not least, the sine a plus sine b, if you add them up, we do it individually, sine of 45 degrees and sine of 135 degrees, you will get square root 2. We can also do that also for any other angles that you add up together, and we realize that the values in the last two columns are not equal. So since they are not equal, we cannot assume, we cannot deduce that sine a plus b is equal. So it is definitely not equal to sine a plus sine b, and hence we need to kind of figure out what is sine a plus b. So over here, I'm going to use this triangle here to kind of like show you what's going on. We have learned how to calculate the area of a triangle using trigonometry. So I'm going to calculate the area of the triangle PQR over here, and these would be half of RP sine A of A plus B, right? So if we are looking at the triangle now, the triangle is, this is the length I'm using, and this is the length I'm using, and this is the angle I'm using. So this is the angle I'm using here. Okay, so with this, we have that. Now we have individually do for each triangles now. So we're going to do for PQS, and we are also going to do for SQR. And we can use the trigonometric area of a triangle to help us find. And we know that the area of a triangle must be equal, right? So triangle PQR must be equals to the area of PQS plus area of SQR. So what happens next is very interesting. I'm going to write them down here like that. Okay, and so we're going to just write what we know, and then I'm going to divide both sides by half. Okay, so what's happening here is that I have just times 2 on both sides, right? So I times 2 on both sides to get rid of the half. Okay, and then what I'm going to do next is I am going to divide both sides by RP, because I want to get rid of RP on the left side. Okay, so since I want to get rid of RP on the left side, so what I'll have now is this random equation over here. Now with this random equation over here, actually we can use basic trigonometry, which what you'll see on top here, okay, which is over here. Cosine A is equals to half of h of r, and cosine B is actually h of p, and we replace them. And do you see that we also have h over p and h over r here? So what we need to do is just replace them, and then we have that sine of a plus b is in fact cosine A sine A plus cosine B sine B. So these actually forms our very first trigonometric identity in addition, and these can be expanded to many other things, which is this over here. This is the list of trigonometric identities that will be provided for you during exams. But in fact, you could actually use the same kind of proof to prove the others. So just now earlier we just proved, we simply just proved the first case, right? I do challenge you all to look at it. Oh, I think I make a mistake here. Alright, here should be sine A HP. Oh, sorry, I made a mistake above. Here should be sine A. Sorry, this should be cosine B, and this is sine cosine A. Yeah. Okay. So no, then there's no mistake here. Okay, so it should be sine A plus B, then sine A cosine B, cosine A sine B. Yep. So as it's the same as earlier. Okay, so I may just make a slight mistake. I replaced it wrongly. Alright, so from here we have the addition formula, and how we're going to use them is very interesting. So we're going to use a very simple work example to actually see how to use them. So first we have these over here. Without using a calculator, we want to find the value of each of the following given each answer in surd form. The clue here is really actually giving your answer in surd form. This means that you have to leave your answers in exact form lah. Okay, so the first step is we have cosine 75 degrees. All angles you can use two angles to add up, right? So from here, I'm gonna break this up to cosine 30 degrees plus 45 degrees. I'm gonna choose angles that are easy to find values for. So remember, we have our basic triangles, which is like 30 degrees, 45 degrees, so on and so forth. Those are easy ones. Okay, so right here, I'm going to apply the addition formula, which is on top over there. Okay, so for cosine, it's very different. It will be cosine A, which is in this case cosine 30 degrees, times cosine 45 degrees, and minus, okay, sine 30 degrees, sine 45 degrees. Now from here, you may be wondering what you're going to do. So you need to remember your basic ratios. So we have, this is 1, 2, square root 3. And we have the other one here, okay, which is 1 and square root 2. Okay, I've never really memorized my basic angles. I've always relied on the triangles. Not the best, but it works. So cosine of 30 degrees would be square root 3 over 2. Cosine 45 degrees would then be 1 over square root 2. Okay, sine 30 degrees, that would be half 1 over 2 times, in this case, sine 45 degrees, which is also 1 over square root 2. Not much difference here. Okay, so from here we just need to simplify. It might be a little bit tedious, but we have square root 3 minus 1 divided by 2 times square root 2. Okay, I'm going to just multiply. Nah, it's okay. I'm just going to leave it in this way. Yeah, okay, yeah, just leave it in this way. So that's how you actually solve this question. Okay, next we have over here sine 37 degrees, cosine 23 degrees. Oh, this doesn't look easy, but if you compare, okay, to the above, this is actually your very first one, sine A cosine B plus cosine A sine B. Yeah, correct. So in this case, this is simply sine of 37 degrees plus 23 degrees, which is in fact sine 60 degrees. Right? Sometimes addition formula can be used like that too, and this will give you this is square root 3 over 2. Okay, and last but not least, tangent. So tangent is a little bit tricky here. It's not easy, so we need to kind of use some things to kind of like deduce these. Now, so of course you can think about what is the easiest way to get 15 degrees. Instead of addition, we can also use subtraction here. So I will say this is 1 plus tangent of 45 degrees minus 30 degrees. You could in fact use 60 degrees minus 45 degrees. That's fine as well. Just that you just need to be careful with what you use later. Okay, now from here, what we're going to do is we're going to apply the tangent. The tangent is pretty tough. You have this 1 plus there divided by that, so we need to get started. Okay, so you just need a bigger space here Okay, this is just brute forcing this. I'm sure there will be a simpler way to actually do this. So tangent 45 degrees minus 30 degrees is actually tangent 45. Okay, feel free to actually refer to the formulas, because these are actually all given. What you are supposed to do is to be able to apply them, and if you're not supposed to memorize these in all. Okay, so I will have something here also, 1 minus, I'm just going to be a bit lazy and copy out this. Okay, because it's actually just the same thing, right? Okay, I know there's a 1 plus, 1 minus and 1 plus. Let's not bother about them first. Let's replace all the values that we know. Okay, so this will be 1 plus tangent 45 is actually just 1 minus tangent 30. So if you look at tangent 30, tangent 30 is 1 over square root 3. Okay, so at the bottom of these, we will have 1 plus 1 times, this is just 1 over square root 3. Okay, from here, we have a very big fraction over here. Not to worry, it's still doable, it's just a bit problematic. We'll have 1 minus 1 over square root 3 divided by 1 plus 1 over square root 3. Okay, now we're going to deal with the fraction first, because it's not the best. Of course, in here, what I'm going to do is individual fractions, individual denominators and stuff. I'm going to make it kind of like a fraction that I can deal with lah. So from here, this will be square root 3 minus 1 over square root 3. Okay, I'm just thinking that I need to be a little bit more accurate in my presentation. Divided. Okay, so what I'm doing is this would be making it to a single fraction. It's a bit tough here, but you will get the idea of why I'm doing this. Okay, this will be 1 minus square root 3 minus 1 over square root 3. The whole thing divided by square root 3 plus 1 divided by square root 3. Okay, this is a bit tedious, really very tedious. You see that my answers are pretty long. Now from here, we can actually deduce that this is actually just 1 plus square root 3 minus 1 divided by square root 3 plus 1. And the bottom is also almost the same, 1 minus square root 3 minus 1 over square root 3 plus 1. Okay, we're going to make it the fraction the same again. So this will be square root 3 plus 1 plus square root 3 minus 1 divided by square root 3 plus 1. The whole thing divided by, this is will be square root 3 plus 1 minus square root 3 plus 1. Okay, because there's a minus there, so it becomes plus. Okay, so we will cancel out the other square root 3 plus 1 again. Okay, so at the top, so let's simplify this whole thing. So when you simplify this whole thing, this would simply be 2 square root 3 and divided by 2. And so your answer is simply square root 3. What a very long method to get there. But yeah, so this is how you use the addition formula for trigonometry. Okay, so that's all.